Hey, welcome back to chapter 3. We're in section 3.5. And we just had gone forward a little bit to 3.6. We're back to 3.5, the polyatomic ions. And these are ions that are charged, and they are comprised of several atoms together. And so let's get our pen out there. They have special names, and there's really no way to know their formulas and have any particular rules on which to name these. There are some, like, which ones have ITE endings and ATE endings, but there are so many exceptions versus IDE endings. There's so many exceptions to these that it's just easier to memorize them or put them on your note card for the exam and the quiz. And so this is in section 3.5, and you need to know this table of ions. It's not a big deal. There's only, about 15 of these or so, 20. But you do need to know that, like, acetate can be written like this also, CH3COO-, or it can also be written like this. But you do need to know the formula, that there are 2 carbons in here, 3 hydrogens and 2 oxygens, so it can be written like this, and the charge is -1, and it's called acetate. Know that carbonate is CO3, and it's got a -2 charge for the whole group, okay? Now, hydrogen carbonate is the newer name. Bicarbonate is the old name. You do not need to know bicarbonate or bisulfate or bisulfite. You need to know the more modern name, which would be hydrogen sulfate, hydrogen sulfite. But you do need to know the charges on the ions and their formulas and their names, and spelling will count. Okay, you will take this piece of information and move on in chemistry 161, 62, and 63 with this information. Now, the formulas do matter. Like hydroxide, it's O, it's Santa Claus, not Ho, it's Santa Claus. It is OH, not HO. And so these formulas are what we refer to, or I refer to, as the gift baskets. There are more than one atom put together in one basket. And so we have 2 carbons in there with the acetate, and 3 hydrogens and 2 oxygens. And the entire thing has cellophane around it with a -1 charge on it. And so you do need to know the charges, because otherwise we won't be able to put together some balanced formulas. So if we look at naming compounds that have polyatomic ions in it, what we have to realize is, where are we going to split the molecule in half? And so we know from our list that this one, NH4, is ammonium. Okay, and so if this is not one of the things on the list in your textbook, but it happens to be one that we're going to look at, is NH4 is the ammonium ion. And then if we looked up C2H3O2, this would be acetate. And so you're just naming them according to what their polyatomic names are. And so if we look at those, for example, sodium, of course, is just named after the metal. And then notice that OH is a group of atoms together. And so you just name it by what was in the table on the previous slide. So OH, it's Santa Claus, is called hydroxide. So we've got magnesium here, and the NO3 group as a gift basket. Notice it has parentheses around it, and the 2 is just saying we want 2 of that group. So it's like writing this down, magnesium with a nitrate and a nitrate. Okay, and so this is just called magnesium nitrate. Don't say dinitrate. It is not dinitrate. Okay, you only use di, tri, tetra with nonmetals and other nonmetals. Magnesium is a metal, so don't use the prefixes ever with a polyatomic group. Here we've got ammonium sulfate. The sulfate ion is SO4. Here we have iron 3-phosphate. Now, iron is one of those transition metals, so we do need to have its charge in parentheses. So therefore, we had to know that PO4 had a -3 charge on it. And by default, then, we would calculate the charge on the transition metal here to be a +3. So it says, what are the names of the following? So let's first of all look at barium, and there's only one kind of element over here on the right side as the anion. And so we have barium is the metal, and it is not one of the names we need to memorize, so that'll be on your periodic table. Just write down the spelling. And then it's just oxygen by itself. So we take the element root ox and add IDE. Now here we have a metal that's in the transition metal land. It's over here in the middle of the periodic table, and so I know I'm going to have to use Roman numerals. So this is chromium, and I'll figure out what its charge is in just a minute. So I'll put that in parentheses. And then I have a gift basket here. So I will have to know that SO4 is called sulfate. Okay, normally ATE, polyatomic ions, it is named after the element with the oxygen, and it has a maximum number of oxygens that it can bond with. Most things, the maximum number is 4 oxygens, except for things like A, B, C. Okay, actually, nope. C, B, can't remember that name. The only other network I can remember, NBC. So nitrate, the maximum number is 3. Borate, the maximum number of oxygens is 3. And carbonate, CO3. So those are ATE ions where their maximum is 3 oxygens. So there's no really set rules, so that's why I just have you memorize these. Now, I have to know what the charge is on my sulfate group to calculate what the charge is on my chromium. So I'm going to deconstruct this. So the charges on the 2 chromiums have to add up with the charges on all 3 sulfate gift baskets here, and they almost all add up to 0. Well, I memorized that the sulfate group has a charge of -2. So what does the charge on each chromium have to be in order for this to equal 0? If you said 3, you're correct. So this is chromium 3 sulfate. We are not going to use the historical name. We would call it chromium 3 sulfate, not chromic sulfate. Okay? So if we're looking at copper 2 sulfate, what you want to do is from a name, you should be able to write down the balanced formula. So write down the atomic symbols, okay, for the elements. And here we're telling you that copper has a +2 charge in this compound. And then sulfate, you'll just have to remember, is SO4, and it has a -2 charge. So we're going to do our swap, drop, and reduce. And so the key thing here is the reduce part, because the 2 and the 2 can be reduced down to 1 to 1. So our formula is Cu for the copper, SO4. I am not going to put parentheses around the SO4. That's incorrect, because I only want one of that gift basket. I only use parentheses around my polyatomic when I want more than one of those polyatomic groups. So you'll see here in the next one, this phosphate group has parentheses around it because there are 2 of them in the formula. So if given a formula, let's write down a name. So CO, you should have memorized what this is. This is cobalt. And then we have PO4, and that's phosphate. And cobalt is in the middle of the transition metals. And I have phosphate is one of our polyatomic ions. So I need to figure out what charge does cobalt have. And what I will find is each phosphate is a -3, and there are 2 of them in the formula. So right now we have a charge of -6 as the anion, which means the cobalts, the 3 cobalts, have to have a +6 charge, which means each cobalt is a +2. All right, here we have iron. It's in the middle of the periodic table, so it's going to have parentheses. So I know I'm going to have iron something. Now, there's only one type of element over here, and it's phosphorus. So I'm going to write phosp the element root plus IDE, because the IDE means it's the element by itself. Doesn't matter if there's two, it's that element, not any other elements. Like here, this is nitrogen and oxygen. There are two elements in that group, whereas this guy is only phosphorus. If we look at chromium here, oh, we got to figure out our charge here. Each phosphorus, if we look at the periodic table, is going to be a -3. So that means that iron here has to be a +2 to balance out. Now, chromium is also in the middle of the periodic table. So it's going to have Roman numerals. And then I need to know that this gift basket is called nitrate. NO3 is the nitrate group. Each nitrate has a -1 charge. So that means 3 of them were needed to balance out the positive charge of chromium. And so chromium will be a +3. Now silver 1 permanganate. Silver is Ag, and it's telling us it has a +1 charge. And the permanganate is MnO4 -1. And so the permanganate, which I think you guys have, it's not in your list, but that's okay. We can look at that. MnO4 has a -1 charge, so if we do our swap, drop, and reduce, our formula is AgMnO4. No parentheses around the permanganate, because I only needed one of that group. So it goes through all my lovely answers. Now, the other thing is we can look at compounds that are said to be hydrated. Anhydrous means without water. And if we look at this test tube right here, it is the white-looking solid versus the blue-looking solid. And so we have copper sulfate, which is hydrated. There are 5 water molecules trapped in between the copper sulfate groups. And so there may be water trapped in between these copper sulfate groups in the solid. And so waters can be trapped in there. And you see that it is a different color than the anhydrous. Anhydrous means without water. Now, when you name a hydrated compound, okay, all we do is use our prefixes to tell me how many of the waters do you have. So here we have cobalt 2 chloride, so this would be named the same way we did before. Cobalt is in the middle of the periodic table, so it needs the Roman numerals. This is chloride, IDE, because there's only chlorine over there. I know that usually if you have an ATE ending or an ITE ending, it's always that element with water. So like ClO3 -1 is chlorate, because it's chlorine with its maximum number of oxygens. But ClO2 -1 is called chlorite, 1 less oxygen than the 8. So ide makes a difference, 8 makes a difference, ite means a difference. So you may have to practice at these, okay? And there's lots of practice problems in mastering. So I'm going to say I have 6 waters. So hexahydrate, the word hydrate just means water. So this is copper 2 chloride, hexahydrate.